Hello, good morning, everyone. Can you hear me? Good morning or good afternoon in our case. Okay, can you hear me? Yes?
Yes.
Yes.
Perfect. Perfect. Sorry, because we had some issues and technical issues, but it's already done. I believe that we already can start with our meeting. We already have all the speakers. We have 66 people already. And in context of the inscriptions, we have more or less, I think we have more or less 130. So I believe that we will have more people join us. So I will start to present very short mode the project, the NERO project, and after that I will pass the floor or give the floor in our. Can you see my screen?
Yes.
Okay, perfect.
Yes.
Yep.
So first of all, thank you very much, our speakers, to accepted our invitation. We are again in our Narrow Network Cafe. This meeting will be recorded and shared in our YouTube channel, so you can see later all this webinar and all the presentations that we will have. Today we have the opportunity to understand better the Canadian wildfire management. We are thinking about the way that we can integrate the science and operations. We will have the both the role dimensions, and we will have the opportunity to understand the way that Canada is integrated the science into the wildfire management. So we will have four speakers: Jan Beverly from University of Alberta, Hilary Cameron to Parks Canada. Also from Parks Canada, we had Jane Park and Neil McLaughlin, sorry if it's not this way, from BC Wildfire Service. Carrie Martins is a fire chief of town of Banff, vice president of Canadian Association of Fire Chiefs, will moderate the entire webinar. So I will try to give you only the overview of the NERO project. The NERO project is a project that we have into the cost action. Cost action is the one modality that we have into the European Commission. You can see more about this kind of modality, because I believe that we have a lot of people here that don't know nothing about the cost action. So you can see here in this website all the opportunities and how you can join also into the NERO network via our website. And also we invite you to view our website and our YouTube channel. The NERO, sorry, because someone has the micro, please turn off. The NERO network, the NERO is the one kind of the networking that we are developing across Europe and also in context of around the world. One of the main goal that we have in this kind of project is try to join science and practices. We had some methodologies, or in this case, we have a methodology to develop some ways to develop this kind of the goals. And one of the things that we can join with us is the short-term scientific mission. This short missions is one opportunity that we have in NERO to found the way that some practitioners and some researchers work together and try to develop some objectives, other possibilities, the virtual mobility, And also we have possibility to develop some conference. We did one and the last month in Cyprus, and we have the intention to develop other one and another country, in this case in 2026. We already did the training schools, and we also are planning to develop more training schools, try to create opportunity to join some researchers and some practitioners, try to develop some subjects or important subjects, and try to see the way that we can apply science in the field. NERO is divided into four working groups. The work group one is one group that um, has the focus to collect historical extreme wildfire events. So the main goal of this group is try to collect information and try to create a database about the fire progressions and the fire progressions that we have with different wildfires. We already have a lot of this work is already done. And in the work group two, we are trying to process and treat all this data, try to convert some information and knowledge, and try to convert part of this information with some doctrine, with some manuals, with some training that we can apply, in this case with the work group 3 that is about capacity building. So the work group 3 is the group that try to convert and try to create this kind of the relationship between all the information that we already have and try to apply in the field. So in context of the capacity building, for example, we are developing this webinar and some training schools and some activities to try to give the opportunity to the people to learn more and share experience. In the end, transversal of all the entire project, we have the communication is work group 4 is about the way that we can disseminate and communicate better with this project. In context of this webinar specifically into the work group 3, we are trying mainly to treat some subjects, important subjects that we can apply in the field. We are trying to develop all these webinars, trying to choose some subjects and work together between the researcher and the practitioner. In this case, is about the reality that we have in Canada. The last one was about Australia, and we will have other one about the United States. So we are trying to see some places that for us works as a reference, and we are trying to create the opportunity to see how some countries are integrated the science into the operations. So if you want more information about the webinar series, we can send information for me that I'm the leader of the work group 3, and also Nuria Prat from Paul Costa Foundation is the co-leader with me. So we are available. You already have our emails here, and you can send all the information that you want. Or if you want to, for example, suggest some webinar, we will be happy to discuss this. So as I said, we have Carrie Martins to moderate the entire webinar. I will share, or in this case, I will stop to share my screen, and I will give the floor to Carrie. Carrie, thank you very much to accept this challenge, and go ahead. Now you are in the command of the the webinar. Thank you very much.
Wonderful. Well, thank you so much, Fabio. I will share my screen here, and well, hopefully I will share my screen.
You will.
Okay. Oh, but not the.
Okay, we can see. It's perfect.
You can see it. All right. We'll just go with this then. We
Thank you.
we don't use Teams, so it's always a bit of a challenge for me when we do. Anyway, good morning, everyone. Really happy to be here and very grateful for the connections that I have been able to make and getting to know folks like Fabio has been a great experience for me and some wonderful learning. I would like to offer a land acknowledgement. These are pretty common in Canada now, particularly since 2015, when the Truth and Reconciliation Commission released calls to action. And those include promotion of building relationships with our Indigenous communities that have called Turtle Island home for millennia. Land acknowledgements vary across the country and are often personalized depending on where you are. The town of Banff, in particular, sits on land inside what has become known as Banff National Park, and that honors treaties that honors the traditional territory of Treaty 7 people. These sacred lands are gathering places for the Niitsitapi from the Blackfoot Confederacy, of whom the Siksika, Kainai, and Piikani First Nations are part, the Yarri Nakota of the Chiniki, Bearspaw, and Goodstoney First Nations, and the Tsuut'ina Nation, the Métis Nation of Alberta, and many others whose histories, languages, and cultures continue to enrich our vibrant community. I am very grateful for the opportunity to live, work, and play on these lands, and to learn from those First Nations and Métis who have lived and cared for this land for generations before me. As Fabio mentioned, I am the Vice President of the Canadian Association of Fire Chiefs. Oh boy, sorry. I was trying to get rid of the text. I'm not sure how to do that. Anyway.
We don't see any text, Carrie.
Oh, okay, perfect. Okay, well then, I'll stop worrying about that. Okay, so then, the Canadian Association of Fire Chiefs was founded in 1909. It's comprised of 7 board members, which are elected from across the country, representing more than 3,200 fire departments from coast to coast to coast. This photo includes the National Advisory Council, which is comprised of each provincial and territorial fire service association. Over the last 2 years in particular, the wildfire threat has been a large topic of conversation and interest across our country. And every year it is one of the many things we discuss with our federal government when we meet them in Ottawa. So just a little context and comparison. Canada has a total land mass of 9,984,000 square kilometers. It's the largest country in the Americas, and we have the longest coastline, bordered on 3 sides by the Arctic, the Atlantic, and the Pacific Oceans. The Rocky Mountains are in the west. Rich farmland covers the central provinces. The Canadian Shield is central and east, and the Arctic tundra is to the north. Canada is home to 369 million hectares of forests, and the recorded population in 2024 was was close to 42 million people. Most of those live in the southern part of the country. And just for fun, I included the coastlines of Greece, France, Portugal, and Spain overlaid on a map of Canada. So wildfire in Canada is primarily the responsibility of the 13 provinces and territories. Each province and territory has its own wildfire agency, and these are all united through the Canadian Interagency Forest Fire Centre, or CIFC, which many of you, I'm sure, are familiar with. Big difference here is obviously they take care of the fires in the forest, and municipal fire departments take care of municipal fires. Across the country, there are somewhere between 3,000 and 4,000 wildland firefighters. As I mentioned earlier, there are more than 3,200 fire departments, municipal fire departments across the country, dealing with fires at the wildland urban interface, communities, structures, local governments, and we have more than 126,000 firefighters in Canada, municipal firefighters in Canada, and 70% of those are largely volunteer or paid on call. 90% of fire departments across the country report involvement in wildland fire. And this number continues to grow as we develop our own data. Historically, we have relied heavily on data out of the US, and we have been, extrapolated that to a certain degree to fit Canadian standards. But over the last number of years, we have been able to start collecting our own data through the Canadian Association of Chiefs. And this is one of those pieces that is important to our members, so it's important to us. Little more data about the numbers. This kind of shows a little bit more about departments that are training in Fire Smart, which is our primary method of mitigation for municipalities across the country. We know that this is, in the long run, how we are going to make advances. So 20% of departments have trained in Fire Smart, likely because the program, though well established in the West, is not as established in the East. And so these numbers we expect will continue to grow as time and effort continues there. 32% of fire departments across the country are not currently getting adequate training in wildfire response, and 53% don't have structure protection training. So this is definitely an area that we as the Canadian Fire Service need to focus on, and will be putting some energy towards as time goes on. 45% need Fire Smart resources to support. And again, Fire Smart is fairly well established in the West, but less so in the East. Few of the things that CAFC is working on, training and interoperability is huge across the country. We would like to develop an FDX Canada, similar to what has gone on in the United States before. Spreading and scoping Fire Smart is also a primary area of focus, as well as a wildfire SAT, and having those conversations at the federal level pertaining to building codes, because we also know that building codes are lagging far behind, and there's a lot that we can do there to move things forward. On the new technology front, Wildfire SAT will be launching, according to the timeline now, in 2029. It is a project of the Canadian Space Agency, Environment and Climate Change Canada, and Natural Resources Canada. So this is an exciting bit of technology that will be coming our way. And I just took this off the CIFC website this morning. It's the active wildfire map and the last sit rep from the 2023 season on September 30th. And I just I grabbed this morning just to show that over 8 million hectares of forest was burned this year. We had close to 6,000 fires year to date. And this year in particular, there were a lot of evacuations, particularly in Saskatchewan and Manitoba First Nations communities, was significant and much higher than before loss of homes and infrastructure. So we also know that across Canada, our Indigenous communities are disproportionately affected by these wildfire incidents. And so that was just a super quick overview, and I believe Jen is up next, so I will stop sharing, hopefully. And Jen, please go ahead.
All right, can you see my presentation in presentation mode?
Yes, we can.
Awesome. Okay, great to be here, and thank you so much for the opportunity to share a bit about some assessment tools that have come out of my lab in recent years. So I'm at the University of Alberta. I'm an associate professor in wildland fire, and my team, Wildfire Analytics, we have quite a few graduate students working on different aspects of fuels, fire behavior, fire risk assessment and vulnerability assessment and exposure assessments. Our website is wildfireanalytics.org, and I'm going to run through a little bit of background about how we're approaching risk assessment, exposure and vulnerability assessments. And these are an effort to inform mitigation decisions. So decisions about where to intervene proactively to manage the fuels and reduce the potential negative impacts of fire. All right, let's see if I can get my slides to advance here. Here we go. So we've already had some background about fire in Canada. Here's some historical context. So this map is just showing fire polygons, so mapped fires going back to 1920. And you can see we have a lot of fire in Canada. Despite fire suppression, fire has not been excluded from the landscape. There's a lot of fire, a lot of regions of the country where fires are, especially in the north, mostly left to burn or monitored as long as they're not impacting communities. In other parts of the country, there's aggressive efforts to identify and detect fires early and suppress them as soon as possible, particularly in populated areas to the south of the country. So you can see most of the fire, though, is concentrated in the boreal forest zone, which is the beige shading on the map. And the only exception might be in the interior of BC, where there's also a lot of fire. But we're even seeing, and I've highlighted fire and impacts to communities in more recent years in places where historically we haven't had a lot of large fires. And when I show these graphs looking at the area burned in Canada going back to 1920, the data is not that reliable, I would say, prior to the 1960s. And so the early years are no doubt missing some of the area burned because we weren't mapping as rigorously. But more recent years, fires are mapped, and you can see we have had some very severe fire activity, especially 2023. The kind of fire that we have in the boreal zone and in many of the fire-prone ecosystems in Canada is perfectly natural. These ecosystems have evolved with fire. Fire is an important agent of renewal in the forests, and this is a natural process of having very intense crown fires. Stand replacing fires move through. They're responsible for most of the area burned in Canada. They kill the trees and remove the biomass in the forest floor and set the stage for regeneration. And in the aftermath, it can look quite stark. And this is a photo I took just last month, walking around in a fire in pine in BC, in lodgepole pine. This is a species, though, that is adapted with fire. Here's another stand that I was also walking through last month that burned in 2021. So this one burned this year, just a few days before I was walking through here, whereas this one burned in 2021. And you can see already there's lots of regenerating pine that's coming in. You'll have another even age stand. So the flaky bark and the serotinous cones are all bound up on these species. Fire comes through. It can easily access the crowns under the right conditions. You get an intense fire, it kills the trees, opens up those cones that pop open, and the seeds fall on a beautiful seed bed to regenerate. So this is an actual, necessary and natural process in the forest. We're not going to eliminate it, nor would we want to, but we are struggling with those very intense fires impacting more and more communities under the kinds of climate conditions that we're getting. 2023 was a great example. These are just images that I grabbed from media and social media showing fire activity impacting communities across Canada, from coast to coast. Every province and territory just about had issues. And so when we have extended fire seasons due to global warming, we have more opportunities for these very intense fires to then ignite, grow large, and interact with values on the landscape. I would say we started to see more and more of these starting about 22 years ago with the Kelowna fire in British Columbia. And then, every few years we've had more and more of these disaster fire events. And they have really prompted a shift away from a fire suppression sort of priority towards proactive mitigation. So can we go and proactively reduce the potential for negative impacts of fire by managing the fuel? At the stand level, so the image on the left, You can go and change the architecture of these stands. This is not ecological restoration. So in other parts of the world and in the US, they are managing the fuels to try to introduce conditions that are natural. And in some places in Canada and in BC, parts of BC, we would see that ponderosa pine, Doug fir, there would be a need to restore a natural condition due to not having regular fire. But in the boreal forest in particular, this is not restoration. When we modify the fuels, it's an attempt to take a natural stand that's fire prone, change the architecture, remove some of the lower limbs, raise the base of the canopy up higher, making it more difficult for fire to do its natural thing and become a crown fire. At the landscape scale, there are efforts to explore landscape level heterogeneity, so harvest cut blocks, anthropogenic activities on the land can potentially introduce barriers to fire spread. We're still trying to figure out how best to do that and if it works. So let's go forward again. The other thing that is done in some locations when it's possible is to do prescribed fire, and that can be to restore ecological health. It can be as part of Indigenous nations cultural burning, as well as for hazard reduction. So the question that we have these possible ways of managing the fuels, but you can't do the mitigations everywhere. So the question is, where can we expect fires to burn? And those then would be the priorities for those interventions, those proactive efforts to manage the fuels. The problem is status quo modeling and the tools that we have had to date have really evolved for fire response. So a lot of the science and the models for predicting what fires are going to do and where they're going to happen were designed for really a different decision. They were designed to inform how to best respond to fires and to predict what the fire is going to do over the next few hours. So it's all about modeling over minutes and hours and days, things like spread distance and intensity, rate of spread and severity. So those models that were designed over many decades through research work done in Canada, we have the Canadian Forest Fire Behavior Prediction System and the Canadian Fire Weather Index System. They were really designed for a different purpose. When in the last just few decades, as we've shifted to a mitigation priority, we're really trying to do something different. We're trying to proactively identify where to act, where to intervene, and we're looking at the next or several years. We're trying to look at large regions prior to a fire, so we don't really know where to focus, and to map hotspots that might guide prioritization of limited budgets for mitigation. So how have we approached this? Well, I want to define the way I'm talking about hazard. Not all definitions are the same. So I'm talking about hazard as a potential source of harm. And I like to use the analogy of a route that someone might trip on if they were walking down a path in the forest. And so there's this potential source of harm, and the receptor in this case would be the person walking down the path. And of course, you need the pathway to connect the two so that harm can plays out. And if, when, and how, and the extent of harm that does play out is going to depend on the characteristics of that route, how big it is it a low profile, how much of the trail is being impinged upon, its extent and its coverage, and you can describe those characteristics. Then it will also depend on the characteristics of the receptor, so the individual that comes into contact with that hazard and their personal individual characteristics. So are they a young person that might bounce back quite easily if they tripped and fell, or an older person, somebody with other impairments, it may be lack of visual perception, there's maybe a better chance for harm to play out because of their characteristics, or a lesser chance. And then you've got environmental modifiers that are going to play out while that happens, and that could be, well, is there low visibility because it's at night, or is there rainy or slippery conditions? So now let's look at that in the context of fire. And of course, yes, there's the connection of the pathway between the source and the receptor. So for fire, the source is the fuel, right? That's the hazard. And the receptor is any value of concern, could be habitat, forests, or structures and values, and whether or not those interact, well, that you can have exposure, you've got hazard and potential impacts, and you've got those environmental modifiers that are going to influence whether or not fires can ignite and spread in their intensity. So whether or not there's been drought, whether you've had ignitions, the wind conditions, and other factors. And in this case, the receptor doesn't walk down the path. Fire is the actual connector between those source hazard fuels and the values and potential impacts. And then if you wrap that up all together, you can go from understanding the possibility of interaction between hazard and values and trying to understand probability as well. Now, if I go back to the tripping example and I showed you, that whole process and said we're going to build a model to try to predict every possible tripping event and the associated impacts, and we're going to do that probabilistically across a large landscape, well, hopefully it would raise concern because it's an incredibly difficult thing to do and probably not going to be very effective because of all the environmental factors and modifiers in particular that can play out, but also just the stochasticity and variability and how those interactions occur and whether or not harm happens. And when values are impacted, it really does take a perfect storm. You've got to have a place where fire can transmit to, so you've got to have that fuel hazard. It has to be a time when the fuel is dry and receptive. You need to have that ignition, which is a human or lightning ignition, and it has to happen in alignment with the wind that pushes it towards more fuel, and that all has to lead to some vulnerable location. After something like this happens, it's very easy to explain it. This is called hindsight bias. So being able to explain what's going on after the fact can give you a false sense of being able to predict it. In reality, it's very difficult to predict. This caused us to really focus on the one thing we do know with certainty and to really try to characterize that fuel hazard and the exposure of values to that hazard. So quite a while back in 2010, published this initial methodology of mapping exposure to 3 different mechanisms of fire transmission: radiant heat, short-range embers, and long-range embers. So this has been adopted in Canada by FireSmart Canada, and they promote it as an assessment tool. And we've been working with it over in recent years to apply it. And I want to share with you some of what that looks like. So here is an example of that long-range ember exposure assessment method for a community in Western Canada called Canmore. And I've shown on the map where that is, the bottom there, where Canmore is, not far from Banff. And I've just zoomed in to show you here, well, that's the mapped exposure of the built environment to long-range embers, just looking at the whether or not and how much fuel hazard is around each location within the built environment. And I've clipped it here to the structures so that you can actually see along a given street, you can have buildings that have different amounts of exposure in that surrounding fuel neighborhood. And this is the same community. I'm just showing you now the shorter range embers, which is 100 meter extent, whereas for the long range embers, we look out 500 meters for ember transmission from those intense fires. We've done these assessments for the entire country, both the short and long range embers, and this is something that we did to assess how well it works. So I made the map for using fuel from 2010 and then overlaid the fires in the years afterwards. And you can see large fires in Canada fall within those big red blobs on the map. What that does is allow you to identify proactively which parts of your landscape can host large fires. And this graph is showing that as the burned area proportion in each exposure class. So yes, most of the fire is skewed towards those high exposure regions of the landscape. So I have a version of that for 2024, and it's also being used in the US as well as in the UK and Portugal. We've also done these assessments. You can incorporate those environmental factors and modifiers after the fact. So we map exposure, and this is an example for Alberta, which is a province I'm in. And you can map the forest FWI system, the fire weather index system components. Here I'm showing the fine fuel moisture code. which tells me which parts of this province is receptive to ignition today. I can put those two maps together so that today I know what is exposed across the land base and what is receptive. And this allows you to also prioritize suppression, pre-positioning of resources, possibly area closures to reduce the possibility of a fire igniting. We've decided, in recent years, myself and my students have been working towards adding on to these assessment methods. So this is an effort to show the directionality of that exposure. So as most risk maps are omnidirectional, they don't include any information about the pathway fire will take. In this example, a value at the dot in the middle has a lot more potential for fire to encroach in from the west than it does from the north. And so we developed an assessment method to characterize that. And this is an example of a fire encroaching in on a community in Alberta, not far from me, in 2023. And our assessments highlight the viable pathways for fire. So these colors are places where fire can move into the built environment. And this shows how well this particular simple assessment captured the pathway that was taken by this fire encroaching in on this community. So there's another example from 2025. This summer, another community we've been working with, this one in Eastern Canada, a First Nation, Pakanjikum. We did these assessments. So the transparency is the landscape exposure. The lines are the viable fire pathways that we've mapped. And this is the modus hotspots of a fire encroaching in on Pakanjikum this past summer. We were able to show this assessment and share it with the province, the fire management agency, the community. They could see the fire had a direct pathway into town. And this was one of the communities evacuated last year. This assessment, the actual mapping, has been automated by a new little software tool developed by my PhD student, Air Forbes. So it's an R package, and you can access it through my website. There's a link, and this is a screenshot of the website where you can download it. But these assessments can be automated with this simple software tool that's open source and freely available for use. Here's another example of that pathway assessment that was done for a community that was impacted last year, Jasper, and we had identified it as one of the top most directionally vulnerable communities in the province of Alberta. And this is a path that the 2024 fire took into that community, which was quite devastating. When you have valleys, with the fuels oriented in valleys, it's easier to map these directions, but this highlights how these simple assessments can help to visualize possible risk scenarios. And the idea being that you can then proactively try to cut off those pathways with fuel mitigations or plan for scenarios around fire encroaching from those directions. Here's back to that example of Canmore. We have the exposure assessment for the built environment. We also have on the bottom the exposure assessment for the broader community. And if you put those together, as well as overlay these purple areas, are fuel management that has been undertaken. And you can see there's been a lot of fuel management to protect against a fire coming in from the northwest. This is the core part of town where there's also been, these are large prescribed fire fuel management out on the landscape. In the center, those are smaller fuel managed areas in the built environment. And we shared these maps with folks in this area. It's to inform a discussion around what if scenarios. So what if the fire does come in from the southeast? It does have a direct pathway. You've got a lot of exposed areas of the built environment in that part of town, and there hasn't been a lot of fuel management. So it's a way to visualize some of the hazards and come up with strategies. So as I mentioned, these tools have been applied in Europe. There's a couple of recent papers from Sidra Khan, who is a PhD student that I co-supervise at the University of Lisbon. And there is, I think, a lot of potential to apply these methods in any fire-prone area. because they are not tied to any specific fire behavior modeling systems or fuel types. They can be adapted for use in other fire regimes, and there's lots you can do. Once you've estimated these methods, they can be inputs to further analysis, and I'd welcome possible collaboration and discussion if you're interested in applying these or learning more about them. I just want to point out some key groups that have funded my lab over the years, supporting this work, as well as key people from my lab that have been working with the exposure assessments, and also Alberta Wildfire and Fire Smart Alberta as well. Neil McLaughlin who is on the call, was a big contributor to the landscape exposure methodology and a co-author on that work. So I will stop there.
All right, thank you very much, Dr. Beverly. We appreciate that, and I think I'm sure there will be some questions at the end. We'll just keep moving on through our presentations for now. And next up, we have Hilary Cameron with Parks Canada.
Hello, everyone. I'll just work on sharing my screen here. There we go. Hopefully you can all see. I'm a little bit blind to the chat, so if anything pops up or there's any questions or concerns, just unmute and let me know. Otherwise, I'll just continue. But hello, everyone. My name is Hilary, and I'm a Resource Management Officer in Banff National Park. I've had a pleasure of working quite intensely with each of the speakers here today, and they've been great mentors and role models to me. So it's a real honor to be able to be a part of this discussion. My goal today is to share some of the insight into the daily operational tools that we use in Banff to predict fire behavior and how that works into planning for safety. Today, I'll start with a quick overview of Banff and the system that we use in Canada to predict wildfire behavior. Then I'll walk through some of the tools that we use as inputs for that system. And after that, I'll describe the tools that we use to detect and respond to wildfires. Finally, I will finish with what's next for us. So let's begin with an overview of Banff. So Banff is located in the Rocky Mountains of Western Canada. The park is almost 7,000 square kilometers in size, with tall mountains and long forested valleys. It's Canada's busiest national park, with more than 4 million visitors each year. The town site can be extremely crowded at times, but the backcountry can be very remote, with some areas receiving only a handful, if any, people passing through annually. It's important to remember that most of Canada, including Banff, is a landscape that has evolved with fire. It's a natural and necessary process here. Before the 1900s, fires were started either by lightning or intentionally by Indigenous peoples who used the fire for travel routes or to support culturally important plant and wildlife species. When Banff became a park in 1885, the government removed Indigenous peoples and banned their burning practices. Combined with a century of active fire suppression, this led to a major fuel buildup and less natural barriers on the landscape to prevent wildfire spread. So as you can see on the right-hand side of this picture here, much of Banff is now surrounded by dense, continuous conifer forests that now burn more intensely and can also spread more easily. Before continuing on, I will say that a lot of work, particularly by Jane, who's going to be speaking next, has focused on reintroducing Indigenous fire practices, but that's a little separate from our talk today. I will say that progress is being made, but there's still a long way to go. So I'll leave that at that for now. However, now that in-government agencies recognize the importance of fire on the landscape, something obviously understood by Indigenous peoples for thousands of years, we now try to let fire play its natural role on the landscape here in Banff. However, this can be a tricky dance with so much infrastructure and people in the park. So we use a zoning approach to guide decisions. Areas with lots of valleys at risk, like towns or highways, are prioritized for suppression. And in this picture here, we've got a couple of our national parks, and the areas in the red of the picture are the areas where we would suppress fire. However, we can maintain ecological integrity in these areas and keep people safe by other techniques, such as prescribed fires or performing fuel treatments like thinning some of our forested stands. In the green and yellow areas that you see, we may allow wildfire to burn naturally depending on the fire danger, the weather, and the available resources on hand. Managing fire in Banff means balancing safety, ecology, and logistics. We rely not just on skilled firefighters, but also on science and tools to predict fire behavior and guide our decisions. For the rest of this talk, the specific details of Banff really aren't that important because many of the tools I'll describe are used across Canada. But Banff is a good example of some of the challenges that we face when trying to predict fire behavior and manage fire on the land. We have steep terrain, unpredictable weather, dense fuels, lots of people crowded into small spaces, and the need to maintain a healthy fire-adapted landscape. Guiding a lot of our decisions that we make in Canada is the Canadian Forest Fire Behavior Prediction System, or the FBP system. I do understand that some places in Europe use this system as well, so sorry if this is a little bit repetitive for you. But the FBP system is a model that is used to assess and predict wildland fire behavior by providing estimates of fire intensity, fire spread rate, or fuel consumption, and fire descriptions, such as if it's a surface fire or a crown fire, so where the canopy of the tree is also burning. The FBP system was developed in the 1970s and 80s by Natural Resources Canada and is based on more than 400 experimental, wild, and prescribed fires across the country. The FBP system provides a consistent, science-based way to assess fire behavior potential across the country and is based on real data. Canada is a big place, and by using the same system, we can move resources around and still all speak the same language in relation to wildfire behavior. As mentioned, with the right inputs, the FBP system can predict those key fire behavior metrics like fire type, rate of spread, fire intensity, fuel consumption, and crown fraction burned. This information is critical for crews so that they know what to expect when they are actioning a wildfire. The FBP system helps us answer important questions like, if a fire were going to start today in a pine stand, will it just creep along the forest floor like in the first photo? Or could ignition quickly escape initial attack control and become dangerous to personnel? Rate of spread outputs also let us estimate how far the fire may travel in a given time, which helps us determine who may be affected and who needs to be notified. The FBP system is being updated as we speak, and it's going through some really big and exciting changes. However, I'm not going to get into that because, one, I'm not the right person, as a lot of great work has been done by some really awesome scientists and practitioners, and two, we don't have the time. But for this talk, I will go over the tools that we use as inputs for the FBP system, which will be the same for the older system and the one currently being updated and implemented. So similar to most fire behavior models, the FBP system requires information from the three components of the fire behavior triangle. So weather, topography, and fuel. I'll spend the next few slides going over the tools that we use to get that information. So first up for us is topography. Topography is pretty simple information to get, and it's important for us because we are in a mountainous environment. And as you know, things like steep slopes and aspects can have a big effect on fire behavior. We use tools like Google Earth to understand where our fire sits on the landscape. And we also use detailed elevation grids that are made with LiDAR, which is a form of remote sensing. And we can use these detailed digital elevation models to apply the FBP system on landscape scales in the event of an actual fire. Another key input is fuels. So in the FBP system, all vegetation across Canada is grouped into 18 benchmark fuel types. Once a fuel type is chosen, the FBP system uses weather and topography to calculate things like fire intensity, type, and expected crown involvement. Canada has a huge diversity of forests and grasslands and environments. So using only 18 fuel types to describe such a diverse landscape can be limiting, but it also helps us all speak the same language and evaluate fuels in a similar way. Fuels are classified into different fuel types based on how the vegetation will burn. And it depends on things like tree species, but also the fuel arrangement, both horizontally and vertically. So is the forest extremely dense, or does it have a lot of ladder fuels that will easily allow a fire to transition from the surface into the crowns of the trees? Fuel calls and the resulting fire behavior prediction can be made quickly in the field by a firefighter with boots on the ground. We would use this method for predicting a small wildfire that may have just started. But once a fire gets quite large, we tend to use fuel maps like the one shown on this photo, and these are often derived by remote sensing. In Banff, our fuel type mapping was created by combining ground observations, LiDAR, and air photo interpretation. The most common fuel types in Banff are the ones that describe our spruce and pine-dominated forests, as well as our open grass meadows in the valley bottoms. The challenge is that the fuel grids become outdated, and our last comprehensive update was in 2016. Since then, the forests have grown and changed just through natural succession, but also through things like wildfire, prescribed fire, fuel treatments, disease, avalanches, and landslides. So we do make small updates as time goes on, but now we're working towards updating the grid with multispectral LiDAR. So the FVP system is also evolving to include more detailed variables beyond those just benchmark fuel types. And it's going to include things like canopy base height, canopy fuel load, and canopy bulk density. So we aren't as limited with just those 18 fuel types. And LiDAR data is a good form of remote sensing that can help us capture this information at a fine scale and with more accuracy. Another tool that we use, especially in the spring, is ground sampling of fuel moisture. So we go into the forests that are representative of our area and collect moisture measurements of the fine fuels at the surface, such as the needles and like the forest floor litter. And then we also collect samples of the duct, which is just below that layer, and that's where the organic matter is kind of starting to decompose. And then we also collect the deeper organic layers below that. And the moisture content in these different layers helps us ground truth the indices that we're using to predict fire behavior. But in simple terms, the litter, how dry that is going to indicate how easily a fire could ignite and how flashy it might be. The duct layer indicates how much fuel is available for the flaming front. And the deep organic layers show drought conditions and whether we can expect a fire to be burning deep underground, making it hard to extinguish. Okay, so our last component of the fire behavior triangle is weather. We use a variety of tools that we use on a day-to-day basis to help us predict the weather and inform us about potential fire behavior or safety concerns for folks on the ground. So out of the three components of the fire behavior triangle, weather is the most challenging input. For current conditions, we use weather stations throughout the park that provide us hourly data. So this is an example here of a picture of a quick deploy weather station, and we've set that up in a prescribed burn area that we're interested in burning later on in the season once that snow melts, and we can monitor the weather. The forecasts come from provincial meteorologists as well as our own interpretation of the weather models. So there is some subjectivity when predicting the weather. To prepare for each day, we compare forecasts and decide what temperatures, humidity, winds, and precipitation are most likely. And then as the day goes on, we monitor with our stations, our weather stations, satellite imagery, lightning detection, and radar, and make adjustments to the fire behavior forecast as necessary. Once we use all our tools, or once we have all our tools and we have the inputs describing the weather, topography, and fuels in the areas we are working in, we can use the FVP system to guide safety and preparedness. For example, if there's no fires currently on the landscape, we use the FVP system to estimate the most likely fire behavior given the current weather forecast and our predominant fuels in terrain. If the FVP system is predicting intense fire behavior, our fire crews may be working on 5-minute getaway times with helicopters stationed nearby. However, if the FVP system is predicting minimal fire behavior, the crews may use this downtime to focus on things like training or maintaining gear or helping out in other places of need. If conducting a prescribed fire, it's a little easier to use the FVP system to guide our safety and preparedness because we already know the weather, topography, and the fuels of that location. In this case, we can brief everyone on the expected fire behavior and make sure that we have the right weather window to achieve the objectives of the prescribed burn. In addition, we can use the predicted fire behavior to make sure we have the right resources on hand for the expected fire behavior. All right, so let's get into some of the other tools that we use on a day-to-day basis. So obviously wildfire detection is extremely important because if a wildfire is in an area that we really don't want it, it's easier to suppress it when it's small. The sooner we get our eyes on a wildfire, the sooner we can start making a plan, whether that's to just let us do its thing or to immediately suppress it. For detection, we often still rely on traditional methods such as people phoning in smoke reports. However, our crews also conduct smoke patrols, particularly during periods of high fire danger, where they try and find smoke across the landscape that may be a wildfire. And we also track lightning strikes closely, so they'll particularly spend a lot of time checking out those places. Satellite-based tools like NASA's FIRM software also help us detect areas that are very hot and show up on a map. And this helps us detect fire growth and fire spread for wildfires or prescribed burns, but it also helps us detect maybe unnoticed fires that are in the backcountry. In terms of response, once a fire has been detected, the fire crew goes out to it and reports things back like the location of it, the slope, fuel type, values at risk, and observed fire behavior. And this helps determine whether to send more resources. We also use this information with the FPP system to ground truth our predictions and forecast how the fire may behave in the future. Sometimes a fire in the backcountry can be left to play its ecological role. We may let it burn freely, or we could do some ignition and tie it into natural features on the landscape, such as a river, and therefore keep it bound to certain areas. Other times, if it's near important values, we need to act quickly to suppress the fire. Some more daily tools for you. So our mapping tools that we use are critical for situational awareness. So we use Esri field maps, which allows us to work off our computers or phones and view layer information, such as those zones I've been talking about, where we automatically suppress a fire if it's in that area, or maybe manage it within natural boundaries. It can also make us notice some values at risk that are in the area, highlight fuel types, past burns, and fuel treatments. And as a fire progresses, we could also map fire perimeters, equipment locations, helicopter landing sites, access routes, danger trees, water sources, etc. And this really helps keep everyone in the same page and keep track of valuable equipment. One issue we have with Esri field maps sometimes is syncing the data, especially because we work in the backcountry. It's hard to keep that data real time throughout the day. All right, other tools that we rely on, remote cameras. This is Mary showing off our remote camera in the backcountry. So we would set up a remote camera maybe to monitor a prescribed fire or a wildfire that's hard to get to, or in this case, we have it focused on a meadow that we want to burn in the spring, and we just want to see when that snow starts to melt. So we set up a camera and it'll send us a photo as the weeks go on, and we can monitor when our window is coming up to burn. We also do flight tracking to monitor helicopters and avoid aviation accidents. We have record keeping system to track weather, resources, decisions made, and timelines. We have radio dispatch for communications so that we can communicate what's going on even when we're far in the backcountry. And on large fires, we have advanced modeling tools like Prometheus for multi-day spread predictions. And Jane will likely talk more about that in her talk that's next. So in terms of research and development, in Banff, we're always looking ahead for better tools. So we've worked a lot with Jen and her exposure tool, checking out areas where we are vulnerable to wildfire. We've also used Burn P3 to assess values in where we are vulnerable to wildfire. The FEP system itself, as I chatted about, was developed in the 1980s and is now being upgraded, which is awesome. But as it becomes upgraded, it's going to require some new inputs and refinements. And so we'll be adapting quickly to make sure that we continue to provide the most accurate predictions for safety and planning. And finally, we also collect a lot of data internally. So we write post-burn reports for prescribed fires or bigger wildfires, and we describe the vegetation pre and post burn, the weather leading up to the burn, the weather during the burn, the notes on the fire behavior, and whether the objectives of the burn were met. And by recording all this information, it allows us to always learn and move forward. And it also gives us some pretty great data to work with other researchers and practitioners such as yourselves. So with that, I will close up my talk that gave you a quick look into the daily operational tools that we use in Banff for wildfire operations and safety. So from predicting wildfire behavior to detecting fires to responding and planning. I really want to thank you for listening and letting me be a part of your talk today. And I think we're doing questions at the end, but I'll take questions later.
Thank you very much, Hilary. That was great. Appreciate that. Okay, and next up we have Jane, also with Parks Canada.
Hi, everybody. I'll just work on sharing my screen as well. You just let me know if you
we can see it, Jane. You're good.
Okay, perfect. Okay, so my name is Jane Park, and I am currently working for the National Fire Management Program as the wildland fire site specialist. As Hillary mentioned, for many years, I was the fire and vegetation specialist for Banff National Park. And I am one of 5 national incident commanders on our incident management teams. And I'll be mostly focusing on that aspect of my job. So being an incident commander and how on wildfires we use wildland fire sites to inform critical decision making. So when we talk about critical decision making, mission critical decision making are decisions that are needed in a short period of time where the consequences of failure can be catastrophic. So in terms of wildland fire management, this includes community evacuations, fire line tactical withdrawals, the use of safety zones by crews and fire line staff, different tactical decisions on what specific fire management tactics we may employ on a fire, as well as kind of aircraft safety and the use of aircraft or the grounding of aircraft, depending on the fire behavior. Situational awareness, is critical for incident safety. And as incident commanders, we need to have the best information to make these decisions for personnel and public safety. And a combination of sound science and experience is key to making these timely and effective decisions. And I'll be going through a couple case studies from the last few years on wildfires where I've got some examples of using science, a combination of science and experience to help make these decisions. The first case study I'm going to talk about is from Wood Buffalo National Park. Wood Buffalo National Park is a very large national park. It's actually larger than Switzerland, and it's in northern Alberta and the Northwest Territories. It's kind of where the red circle is there. And the fires that started there started in June. That's fairly typical of that area. They're lightning-caused fires, and they quickly kind of spread under very dry conditions and burned a total of over 500,000 hectares by the end of the season. What I'll be talking about is the evacuation of the town of Fort Smith, which is a moderately sized community based in the Northwest Territories. And the kind of the information that we use to kind of push that community or recommend to the community for an evacuation alert at the beginning part of August, and then the subsequent fire behavior and weather that resulted in their evacuation order on the 12th and this critical spread event on the 13th. So for context, there was consistent extreme fire weather forecasted from the fire forecaster. So each province and territory generally has fire weather meteorologists. In this situation, for almost a week, the local meteorologist had been predicting extreme winds from 50 to 60 kilometers an hour sustained, with gusts up to 80 kilometers an hour. That was over a fairly large area. And the communities of Fort Smith and Fort Fitzgerald were downwind of the fires that we were working on, resulting in us making recommendations for evacuation alerts and orders. Other fires in the area were around multiple communities. And Hay River, which is approximately 236 kilometers east of the community of Fort Smith, was designated as the reception area for evacuees from Fort Smith. And that type of decision is made at the territorial level by the Municipal Affairs Department in the territory, but on recommendation from Wildfire. So if you look at the map here, you can see the community of Fort Smith. There's another smaller Indigenous community called Fort Fitzgerald, just kind of southeast of the community. And then Hay River is just outside of this frame, 236 kilometers west of Fort Smith. And there's only one road. This Highway 5 is a critical transportation corridor in and out of the community. It also houses critical infrastructure in terms of the power lines and communication infrastructure. So it's very critical in terms of fire and its vulnerability to the town of Fort Smith. On the 10th of August, we issued an evacuation alert. And this was based on, Hillary was actually the fire behavior analyst on my incident management team at the time. And it was based on Prometheus projections. You can see some of them here on this map that show kind of the potential spread distance in the following few days and proximity, kind of the spread distance, 5 kilometers. And then we had set kind of predetermined decision thresholds based on communities, where we would recommend an evacuation alert when the fire was approximately 15 kilometers from town, or an evacuation order, which means community members and the public would be ordered to evacuate if the fire was predicted to approach up to 10 kilometers from town. This provided, in our opinion, enough time for residents to evacuate along that highway corridor. And so when we issued the evacuation alert on the 10th of August, the community, there was quite a bit of compliance. The interesting part from a human and social perspective is that many people, went to the grocery store, went to the gas stations. There was huge lineups at the gas station. There was a bit of a perception of panic, but, in our opinion, from the incident management team perspective, this is a good thing, because what we do want when we issue proactive alerts is for people to be prepared to leave on short notice. And so having folks go and gas up their vehicle, given that the reception center was over 200 kilometers away, is a good thing, because what you don't want is for people to be doing that with the fire approaching and running out of gas, or there being issues like that. So while in terms of supporting these decisions, both Hillary as well as my plan section chief were very busy for the few days leading up to the critical weather event. I quoting this, I don't know, Hillary can probably correct me, but we did probably over almost a dozen different Prometheus model runs. So Prometheus is a fire spread model that incorporates the fire behavior prediction system that Hillary just talked about, takes, the fuel grids that we have and runs it through a commuter model of varying iterations. So we adjusted for varying wind forecast. We kind of refined fuel data based on what we were seeing in the field for field observations of fire behavior. At the same time, because these decisions are so critical, my plan section chief was also kind of checking the computer math with manual forecasting using FBP as well, just to try to verify the models so that we were sure to be using the best information to inform the public. And so the map you see here is, one of those manual model runs, you could say, of the plan section chief. I'll be showing some of the Prometheus model runs that Hillary ran. And when we're making these types of decisions, my kind of tactic is really to err on the conservative side when recommending evacuations, just because I would rather be kind of wrong on evacuating a community early and having an orderly and calm evacuation, as opposed to one that is a lot more dangerous, but also perhaps more traumatizing to the community members. So here you can see various Prometheus model runs based on the weather that we had. And you can see the community of Fort Smith here. This is where our incident command post was, and Fort Fitzgerald over here. And you can see that the fire was predicted to get fairly close to both the community and of Fort Smith and Fort Fitzgerald, and also to impinge on that highway. We had been working on these fires for several months and making quite good progress. This is the NASA FIRMS map from the 12th, so the day before the critical fire day. You can see that there are very few hot spots. Obviously, we knew there was heat, and we had crews and heavy equipment and aircraft working on the fire. We had 18 aircraft, multiple heavy equipment units. In this area to the west, there was a cat guard right abutted to where this heat was. We had crews actioning it. And same with over here. We had definitely some containment actions, and these lighter features are actually natural features. Those are salt flats that are non-fuel. But obviously with the forecasted weather, we knew there was potential for spotting over those areas. We also had structure protection and crews kind of fortifying our incident command post. We were located near the airport, and you can kind of see the runways there that provided us some protection as well. And so it was a matter of trying to get as much containment done as possible prior to that wind event. We knew that because of the forecasted winds, our aircraft would likely be grounded as those winds increased. And the safety of our wildfire personnel and the fire crews and the heavy equipment operators was the number one priority once the actual community was evacuated. And so we did get the community we had a recommendation for evacuation order on the 12th, and we had fairly good compliance. There was a small group of community members that did not leave the community. In the Northwest Territories, there isn't legislation necessarily to force people to leave, but we estimated that approximately 70% of the community did depart when the order was put in place. But we did have to be cognizant that some community members refused to leave and were still in the area. On the 13th, we had indications very early on that it would be a very critical day. This is a photo from our incident command post, but even as early as 7 o'clock in the morning during our morning briefing, we had sent some crews out very early to try to deal with some of that heat that we knew was right adjacent to that cat guard. And the first helicopter bucket machine to go quiet the hotspots down and to deal with spotting over the cat guard started about 7 o'clock in the morning, which was not a very good feeling and definitely an indication of what that day had to come. Because at that point, the winds were not as strong as forecasted at the peak of the incident, but they were already starting to build very early in the day. This photo was taken approximately 14:30, so 2:30 in the afternoon. You can see the color of the sky as the fire approached. By this point, all aircraft was grounded. That's why you can see all the aircraft on the ground there. The winds were consistently 40 to 50 and gusting much higher by this point. Only half an hour later, this was the scene at the incident command post. It was obviously very critical. We had no fire personnel left on the line at this point. And we were basically had structure protection running at the incident command post. We were in good communication with the territorial wildfire personnel, as well as an Alberta incident management team that was also in the area on a different fire. But it was obvious that the fire was taking a major run, though, because we could not really be in the air at this point. It was unsure exactly where the fire was heading. This MODIS map here, or FIRMS map from NASA, is actually from about 10:45 p.m., so 22:45 that evening. We could see, if you compare it to earlier in the day where you barely saw hot spots, you can see just how fast and far the fire did move. And it continued to move, through the night. So Fort Smith is just up here, and the fires that we had kind of seen, the hot spots were over here. So you can see just how far things moved, even in the evening. And the fires up here are from a different fire that was north of the community as well. So here's a kind of final estimation of the fire spread following that event. You can see where the Prometheus models did predict pretty well some of the spread, but there was a long finger here that was not predicted and went much further. What we do kind of think based on the fire behavior and what we do know about convective columns and their potential interaction is that we do think that potentially some of the convection just southwest of Fort Fitzgerald interacted with the column near Fort Smith, and they kind of drew into each other. So you can kind of see that it got pulled this way quite a far distance. That distance actually is quite far. As I mentioned, the park is very big, and it moved over 40 kilometers in that 12-hour period. That day was critical across the region. And so here's Hay River. This is where the reception center was. That's the distance between Fort Smith and Hay River is, as mentioned, 236 kilometers. And so when we did evacuate the community the day before, they were directed to go to the reception center in Hay River. On the 12th, the pathway to Hay River was safe and it was done in an orderly fashion. Unfortunately, because of the critical wind event, the evacuees were subsequently evacuated from Hay River, where their reception center was, out of the area. And so, unfortunately, that evacuation occurred during the critical fire behavior. And so some of those evacuees faced a fairly frightening evacuation. And it just goes to show in terms of kind of coordinating things over a large landscape and ensuring that all the different levels of government have good communication and understanding of those critical weather events is really important. You know, we're next going to move. So that was in 2023. And so that was up here in the Northwest Territories. We're now going to move to this year, where in Manitoba. So if you just, Manitoba is one of the central Canadian prairie provinces, actually where I grew up. And we're going to go to central Alberta. So we were, my incident management team this year was deployed to Flin Flon initially, which is a very large fire up near the Canadian Shield. So it's a lot of granite lakes and jack pine forests. That community was evacuated earlier in the season. We were there kind of as that fire, which was several 100,000 hectares, was dying down, and it was in kind of mop-up stage. But the trend in the weather was an uptick in fire danger and fire behavior. And very soon after we got there, there was another lightning storm that came through, quite a aggressive one with a large hail and a lot of lightning. It started fires kind of all around us. And very quickly, we went from being deployed to one fire to inheriting at least a dozen or more fires over a very large area. So in the end, our complex stretched from Flin Flon on the Saskatchewan-Manitoba border all the way to a smaller community in central Manitoba called Snow Lake, and then all the way north of Puckatawagan. So we had almost 500,000 hectares of fire in an area kind of in this region of Manitoba. I'll be talking more about Snow Lake, which is a small community to the west. And just for context, this wildfire season in Manitoba was the worst fire season in 40 years. This community was a population of 1,000 people. The primary industry is mining for like metals like cadmium, gold, silver, and they have a large industrial underground mine there with approximately 600 plus people in a camp there. Again, similar to Fort Smith, Canada has a lot of remote places. There's only one road in and out of there. So again, as a team and as with my plan section chief, the same one that was in Fort Smith, we really had to keep a keen eye on the fire behavior, the weather, and the threat to both the mine and the community while we were still monitoring a dozen other fires kind of in the region. And there was also other industrial locations like hydro installations and with personnel and dams and things like that as well. You can see in this lower picture kind of what the fuel looks like. For those who are familiar with the FBP system, a typical C3 stand is a jack pine stand. It has 4-meter crown base height and is fairly well stocked. This is a lot different. It's jack pine, but on Canadian Shield, and it's got fairly rolling topography. You can't see very many lakes in that photo, but there are, in that region that they say it's a land of 100,000 lakes. And so there are many little islands, slight little rises, and the fire was kind of spreading on those places, getting up to the height of land and then spotting very far. And so we used a lot of observations from the fire folks on the ground, the Manitoban division supervisors and crews, and we verified rates of spread on big spread days, and it behaved more like C2 than it did either C1, which is kind of an more open coniferous fuel type, compared to the lodgepole pine C3. So when the plan section chief was running her predictions, we did not have an FBAN fire behavior analyst on this fire, unfortunately. But thankfully, my plan section chief also can wear two hats. She was using the C2 spruce, boreal spruce fuel type for her predictions. You can see the spotting distances here in this photo. This was one of the critical fire days when we had to evacuate the mine. It made a big push towards the mine and it needed to be evacuated. That was already after the town was evacuated. So in this case, because we did not have an actual dedicated fire behavior analyst, my my plan section chief used fairly basic fire behavior modeling. So just used our red book, the FBP system, what we knew about the fuels and how they were behaving, and the weather forecast from the provincial meteorologist to model fire spread distances relative to the town. And so you can see some of, depending on the wind, if we had a southwest wind, how far the fire might go. The mine is right here. The community is just outside of this picture. And on this day in particular, there was going to be a southwest wind followed by a northeast shift with cold front passage that would directly put the mine in its path. So you can see here with the wind shift, the mine would be in the path. We also, she used Firestar, which is kind of a model that looks at probable spread distances to determine triggers for evacuation. You can see the community here. And so we recommended the town of Snow Lake be evacuated on the 10th. The mine site was still operational. It was kind of different timing just based on kind of critical staff that remained in place. It was evacuated and shut down on the 12th. And this fire did continue to cause issues for both of those, both the community and the industrial infrastructure for another month and a bit. And the evacuation of the community was finally lifted near the end of August. So the key lessons learned, as an incident commander in charge of the safety of both the public and personnel is that, we really do have to rely both on the science as well as field observations to really validate those models. We do need to understand the limitations of those models and assumptions. Jen mentioned, some of the difficulties with modeling, and Hillary mentioned, our difficulties in predicting, finer scale weather over a very large geographic extent. And, but using as much as we can, even in the cases where we didn't have computer models, the fact that the FBP system has continued to be refined and tested, and we do understand kind of how to look at it and maybe squint at the inputs and outputs to meet the needs of our particular incidents. All of those kind of experiences in science contribute to our ability to make those critical decisions for both public and responder safety. And again, like all the other presenters, I'll wait for questions at the end. Thank you.
Great, thanks so much, Jane. And Neil, we will go to you next.
All right, thank you, Carrie. Thank you to all the other presenters. We were connecting before the call started, and we're sharing comments that it's a bit like a bit of a reunion party. We don't get to see each other a lot. We work across the vast country of Canada that Carrie shared with you on the map, and often get to see each other when we're on fires or when we're on webinars like this. So this has been fun, and I really appreciate the other speakers kind of setting me up for success in what they've shared with you this morning. So let me share my screen with you while I click some buttons here. All right, should be seeing some helicopters with the title slide. If you're not, someone just let me know.
No,
so
you're good, Neil.
Oh, thank you. My name is Neil McLaughlin. I am the Superintendent of Predictive Services for BC Wildfire Service. and relatively new to the province. I moved here just coming up on 5 years this January. And it's been a wild ride the last 5 years. So I'd like to share some of the stories and kind of have the task in this last talk to link research with field response and kind of demonstrate how we're bringing science into operations. And so in sharing some of my stories, I will endeavor to do that. But I thought I would start by providing a quick overview of BC. It's a big place. Really what I want you to get away from this slide is just a number of different scales of management. We typically think about fire in terms of a single incident, a single fire burning and threatening something. And so, you know, looking to the left of this slide, you've got kind of these bullets, and that's down at the bottom, the incident level. But really, in BC and any agency across Canada, there are other scales of management that are occurring simultaneous. And I really wanted to highlight this because I think it'll kind of come up in some of my comments later in the presentation. But looking at the map of the province on this slide, we divide the province up into 6 regional centers. Those are the darker black lines. And then within each of those, they are further divided down into what we call fire zones. And so if we just kind of think about what this looks like on a typical day in the summer, we start getting fire starts across the landscape. The first scale that actually interacts with those fires would be our zones, our local zones, and they're going to be dispatching fire crews to those fires. And that might be where it stops, but within those larger regional fire centers, the allocation of those firefighting crews and resources is being coordinated at the regional center. If some of those fires escape initial attack and become large problem fires, that's where we might bring in an incident management team, and it would work down at that lowest scale. It's on that incident level. But as we're doing that, some of the resources that we would use for initial attack, like air tankers, or some of the resources that we might use for sustained action on larger fires, like our unit crews, are provincially allocated. And that would be the coordination of our headquarters at the very top. And so all of these scales are interacting and working together throughout each day of the fire season. Some of them are thinking on longer terms time horizons as well. So typically at the incident level, we're thinking 1 to 3 days out. As we move up into that local zone and regional fire center scale, we're thinking more the next week to potentially 2 weeks. And certainly at the provincial level, we're thinking 2 weeks out to a month. At the provincial level, that's a key coordination role in terms of bringing in resources from across Canada and the world when we have busy fire seasons. And so really what I wanted you to take away as I kind of explain these 3 scales, some of my examples I'm going to provide are kind of at the incident and maybe moving into the local zone scale. But it's been my experience, we've got lots of science and lots of tools down at those lower scales and shorter time horizons. And as you go further up the food chain, the number of tools, the availability of intelligence and science to support decision making really starts to, there's a real attrition. And so I just wanted to highlight that for researchers that are on the call, interested in doing operational research. We've got lots of stuff down at the bottom, but we need more at the top. And so let's keep going. That's BC. We're going to talk about a couple examples throughout the province here. I want to set some context. So we're going to zoom in on some fire examples from the northeast corner of the province of British Columbia. And on this slide, I'm showing you fires that have burned in our northeast corner of the province over the last 3 years, so 2023 to 2025. That is the map on the left-hand side of the slide. These fires ranged in the tens to hundreds of thousands of hectares each. Many of them overwintered for 2 to 3 winters in a row, burning under extreme drought conditions. And at the end of the day, the two northernmost zones you're seeing in the map, the zones of Fort Nelson and Fort St. John, both saw over 20%, close to 25%, in fact, of their forested land bases burn within a 3-year period. Now, the map on the right is showing you our fire history since recorded history began in 1950 all the way to 2022. So that's 73 years of fire history in gray on the map on the right, and the past 3 years of fire history in red, again on the map on the right. And what's fascinating but also terrifying is that the amount of area that we burnt in the last 3 years is equivalent to what we burnt in the last 73 in this part of the province. And so we are seeing rapidly changing fire regimes in our north. Our boreal forests are drying, permafrost is melting, and this is a fire-dominated ecosystem. A lot of the forests are adapted to fire, as Jen articulated in her presentation, but the rate at which we're burning now is pretty significant. And now you can go back in time and you can find an example of a 1.5 million hectare fire that burned across the BC-Alberta border back in the 1950s. But there was only one. There's only one of those fires. Looking at this map, we had several of those fires burning simultaneously. So that's part of the context. And looking at it another way, this is just adding up area burned. Dr. Beverly showed a similar graphic in her slide. For Canada, this is a slide for BC showing total area burned by decade since 1950. The last bar on the far right is our current decade. We still have 4 years to go, but it towers over all the rest. In fact, it pretty much similar to the statistics I was sharing for our Prince George Fire Center, it pretty much is equivalent to almost every other decade from 1950 to the end of the 2000s. And so quite alarming. And so the message I wanted to share in setting the context is things are changing fast. We just went through a fire season this year where we burnt close to 900,000 hectares in forested area. And we're kind of talking about it as if it was a normal year. It's not normal. Look at the amount of fire that we burnt in previous decades. Some of those decades didn't even get to 900,000 hectares, and we burnt that just this past year, and we're kind of referring to it as a more normal year. Things are changing fast in BC, and there is a real need for applied and operational research. And so I'd like to share a couple examples and stories of how more recent research is being integrated into our field operations. But in doing that, really call out to the community that we need more operational research. And I fear that the pace of research can't actually keep up to the pace of our changing climate and fire regimes. And so if you're interested in doing applied operational research, give me a call after this webinar. But let's get into it. But there's a lot of really neat things being done in the research community, and I don't have time to highlight all of them, but I'm going to pick out a couple and demonstrate how we're kind of bringing the concepts of that research or leveraging it in some of our field operations and decision making. And so the first one I'm going to start with is spread event days. Back in 2011, Justin Poder and Mike Watton published a paper defining spread event days for fire growth modeling. At the time, it was novel. The intention was to improve our fire growth modeling, and that fire growth models don't deal well with extinguishment, and they always predict a rate of spread that's looking at things in meters per minute based on hourly weather. And so in a nutshell, you often saw over-prediction until such time as you didn't, and then they would underperform. And so, you know, the amount of times that your model matches reality, I would say is like 1 in 10, and maybe 3 out of 10 times you're somewhere in the ballpark if you put some human intervention into your fire growth model. The other half of the time, they're really wrong. They're either grossly over or under predicting. And Jen talked about a couple of those reasons why that might be. But the neat thing about this paper is that it was trying to deal with that over prediction problem. And the statement here that's in quotations was kind of one of the key conclusions of that paper, is that they were looking at least in the Northern Boreal in Canada, a fire weather index of 19 or greater as defining a spread day. This would be a day when you expect a fire to be moving and conducting across the landscape. That took hold in the fire community in many agencies here in Canada, but almost as a rule, as opposed to a probability, which it was expressed as in the paper. And so that's the graph on the right. And so in the research, when you achieved a fire weather index value of 19 or greater, that was equivalent to a 50% likelihood or probability of spread. And so a coin toss, half your fires would spread, half wouldn't. And so it did in fact improve our fire growth models, but I want to share maybe how it's been kind of integrated into some of our decision making and how we've maybe tweaked it a little bit. Before I do, I'm going to share a little bit more about the theory of these spread event days. One thing I want you to pay attention to on this graph, which I find really interesting, there's 2 different colors of dots on this graph. The gray are suppressed fires. Those would be seeing action from fire crews and suppression resources. And the dark black dots are observed fires. So these might be fires that were being monitored or had very little suppression on them. What I find fascinating about this graph is there's not really a difference between the probability of a spread day or a non-spread day when looking at suppressed and non-suppressed fires. So very interesting. Anyways, another paper came out in 2023, a very recent paper by Zhang Li et al., Critical Fire Weather Conditions During Active Fire Spread Days in Canada. Is essentially built upon the paper I just shared with you, but it looked at things across Canada. In the maps on the right-hand side of the slide, they're showing a number of different analyses they did on the fine fuel moisture code, the initial spread index, and the fire weather index. And so the lowest panel would align with some of the recommendations that came out of the Podur and Watton paper. But essentially the conclusions that came out of that paper is that you can't use that rule, that fire weather index of 19 or greater everywhere in the country of Canada. And even within a province, there's some regionality that needs to be paid attention to. And so this paper endeavored to provide a little bit more precision in terms of using spread event days in decision making by breaking the country up into large ecoregions and doing an analysis at that scale. They also found that the conditions may be a little bit different over the seasons, so between spring into summer and then late fall. So I'd like to share an example of how this has been used. And so you're looking at a picture of the Donnie Creek wildfire. This is one of those big red blobs on the maps I shared earlier. This fire grew to over 500,000 hectares in size. You're looking at one of the spread days back in June of 2023. In sharing this story, I want to give a lot of credit to 2 of my predictive services officers, Ben Boheen and Eric Kopetsky. They spent a lot of their summer holidays watching and predicting fire behavior up in Fort Nelson and Fort St. John. And so really what they were doing was kind of leveraging the concept of a spread event day and watching for conditions where you had a fire spread or you didn't. And so in essence, maybe acknowledging some of the findings from the Zhang Li paper and looking at how they could refine it regionally and by season. And they took it a little step further. Rather than just saying, will it spread, yes or no, they added some rough distances in kilometers per day. So we're not looking at rates of spread in meters per minute, but just a rough estimate of this is how many kilometers the fire could move per day. And so the table on the left is an example of some of their conditions they were watching for. And they really broke it down into two main categories, a 1 to 5 kilometers daily spread and a 5 to 10. Obviously, conditions that fell below the 1 to 5 would be a non-spread day. And we did at one point have conditions that were above the 5 to 10. We did see 40-kilometer daily spread distances under some more extreme conditions, but those were the exception, maybe not the norm. And so how did we use this? Let me share an example. Excuse me. This is a really busy map. These are usually printed out on a big wall map, and they're a lot easier to interact with standing by the wall and looking at it up close. But I have zoomed into a certain little segment of the map, which is on the lower right-hand corner. But essentially what Ben and Eric were doing was using those rough heuristics that kind of were founded on the spread event day principles, just with some local refinement based on observation of fire over weeks and weeks and weeks in the north. They would look to the forecast and determine if those conditions were met or not, and do simple math. We're expecting a 5-kilometer day today. We're expecting a 1-kilometer day. And instead of trying to grow the fires, because what you're seeing on this map, all of those red areas are the fires. That is a lot of modeling to do. And when you put a bunch of models on fires that size, you get a bunch of big amoeba blobs and a big mess on the map. And it's really hard to manage. And so they actually worked from the values. And so the black dots you're seeing with yellow around them are the values. And then in this example, they've been buffered by 10 kilometers. And so the concept would be, I mean, we don't have a full-fledged tool to do this. There was some human intervention on the incident management teams, but they would forecast the conditions, they would determine the spread distance and draw a buffer around the values. They would then look to see, is there any active portion of fire perimeter falling within those buffers? And they would then essentially eliminate all of the buffers that didn't intersect with active fire perimeter and essentially net down the scope of the problem. And so when you look at this map, it looks crazy because it is. The incident management teams that were working in that zone that year were overseeing all of those fires. This is actually from this spring, the map I'm showing you here. Imagine managing all of those fires and all of those values simultaneously. So I made the comment earlier that things are changing fast. Our incident management teams are very infrequently managing a single fire incident. They are more typically now managing multiple large landscape scale fire complexes that are threatening multiple values across large areas. And so this exercise and why it was so beneficial to field observations was really a scoping exercise. How do you net down a busy land base and provide focus to an incident management team and to the firefighting resources we have so that we can do effective work and achieve outcomes with respect to public safety or values protection when you've got so much to look at? And so this simple heuristical approach worked quite effectively and could be done quickly. So that's one example. I've got a couple others. You heard about exposure modeling from Dr. Beverly. This these examples are from one of the papers that was authored by one of her PhD students, Ariel Forbes, and looking at directional exposure and essentially fire pathways. And so this example fire is from their paper. I think it's an Alberta wildfire. You can see some spread trajectories that are mapped throughout the fire. And essentially the graph on the right summarizes across close to 600 sampled trajectories that those spread pathways exhibited extensive overlap with high exposure areas. And so this gives us another kind of piece, and you might think as I go along in these stories that I'm kind of rebuilding a fire growth model, and I might just be doing that, but in a different way. And so this is kind of another piece of the puzzle. So in what we just looked at with the example from the Prince George Fire Center, just using buffers kind of ignores the fuels. You might have a buffer that's intersecting a community and active segment of a perimeter, but there may not be high exposure fuels between the two. And so I'd like to share you another example of how this research was being used actually this fire season. And so this is another operational map. It's going to look busy. It's going to be hard to read, but I'll walk you through it. So this is the Kaskatna River fire. It started in May of this year. It was located 60 kilometers from Dawson Creek or 40 kilometers from Tumbler Ridge. It was essentially on the border of BC and Alberta, and it did spread into Alberta. It spread about 30 kilometers, and it engulfed a community of Kelly Lake, which you can actually kind of see on the map. It's right in the center of the fire, and there's kind of a little green box around it. And so when I was on this fire with the incident management team, I was asked to help complete an advanced plan that would determine how we transition this fire back to the zone or an incoming incident management team that would take over from us, but also how to set up some criteria that could be easily monitored, that could be used to inform evacuation alerts or orders, and essentially provide timelines if certain points on the land base were breached by the fire. And the rationale for that is that our incident commander really didn't want to have communities displaced all summer long. These northern areas, that's been their life for the last 3 years. And so really a key principle we were trying to uphold was containing the fire quickly as possible and allowing people to re-enter their communities as quickly as possible. And so we were looking to be more dynamic with evacuation alerts and orders. And so as we worked this fire, we did remove those evacuation alerts and orders and allow communities back in. But we wanted to have a mechanism to turn them back on if needed and be able to provide advance notice. And so let me just kind of walk you through the 2 areas in BC that you're seeing on this map. Area 1 is to the north, Area 2 is to the south. They're essentially identifying areas that had values at risk that we were concerned about. Area 1 had a community of One Island Lake. It had some residences and properties in around Cutbank Lake. There was a recreation site and there was oil and gas infrastructure. Area 2 on the bottom was primarily oil and gas infrastructure and kind of bordered on a recreation site. And so in this map, which is difficult to read because it's a fairly large scale wall map again, there are some lines. So there's a green line within Area 1 and there's a purple line in Area 2 on the south side of the fire. And those lines were essentially decision lines. If the fire reached those lines, there may be a decision to activate an evacuation alert. And if it breached them, there would be an evacuation order. And we would know at that point that we had approximately 1 to 2 days before the fire would reach said values. And so a lot of this work was actually informed by an exposure analysis. And so using the fire exposure R package that Air Forbes created, I created the map that you're seeing on this slide, where, colors of yellow and red are indicating areas of higher exposure and areas of blue are lower exposure. Again, Jen shared a couple examples of this, but I just find it fascinating how it aligns with where the fire stopped and what the fire burned through. And so overlaid, it's a little bit busy. If you squint your eyes just right and look inside the boundary of this fire, you will see a bunch of internal polygons that are slightly shaded. That came from some work with our data scientist, Ashlyn Richardson, working with Sentinel data. He's got some novel algorithms to be able to describe what has burned inside of a perimeter. It also allows us to track how perimeters are growing over time, which I'll speak to in a moment. But essentially, looking inside that fire, you can now see what predominantly burned and what didn't. And there's even better alignment compared to the external perimeter with those high exposure areas. And so as I did this analysis, this is what informed where those decision lines were. You can see the high exposure or dark red colors beyond the fire to the northwest and south of the fire perimeter. And that is where those lines showed up. We knew that if we had the fire breach its current perimeter and get into those areas, that was the same kind of fuel complex that those initial runs had moved through. And similar to Eric and Ben, I benchmarked what that fire had done under certain conditions to determine timelines for getting structural protection crews into those communities and getting people out of harm's way. I want to share where we might be going with this by referencing one more paper. This is a paper from 2015 by Owen Price and others in Australia. It's looking at an empirical wildfire risk analysis. Essentially what their analysis did, it looked at the probability of a fire spreading to the urban interface. They were looking at a study area in Sydney, Australia. Essentially, they had a large number of fires where they knew the location the fire started. They knew the location of values surrounding the fire. They drew trajectories or lines between where the fire started and values it could impact. And then they looked at a bunch of different parameters, similar to what I was just describing, to determine the probability of whether the fire would reach said value or not. In their study, they found that fire weather had the strongest influence on burning likelihood, followed by the percentage of the line that was forested. So think about exposure, right? High exposure areas are typically got 80% more of that trajectory is under high exposure values. So distance and time since last fire. So they did see that past burns had an influence on dampening the likelihood that a fire would reach a value if there was a past or historical burn in between. And what I really find neat about this paper is that the model captured 90% of variation in burning with 98% predictive accuracy on test data. That is incredible. I have yet to see a simulation fire growth model with that kind of accuracy. And so this is a different type of modeling. It's not simulation modeling where we're putting a fire on a map and creating what looks to be a realistic simulation of growth on a map. Instead, we're modeling different parameters that are maybe easier to obtain and give us a high level of confidence in terms of an outcome and can inform an operational decision. And so looking forward, this is a bit of a refinement pathway that we are interested in going down in what I just shared with you. And so what's been really fun working with my team and our fire behavior analyst is seeing that refinement over the past 3 years. And as we gain experience using some of this science, how we can maybe improve upon it to get even better predictions and provide better intelligence and direction to our incident management teams and operations. And so, looking at the first step here, forecasting conditions known to influence fire spread. For the most part, we're using the Canadian Fire Weather Index system and weather observations to do this right now. There are some neat opportunities to look at things like the Hot, Dry, Windy Index, which we use in our weather briefings. And if you're not familiar with that index, it looks at the near surface level, we'll say the lower atmospheric levels, and it's looking at vapor pressure deficit and wind speed in those different pressure levels. And what it's good at doing is detecting when you might have a really dry and windy air mass aloft that hasn't mixed down to your fire yet. And so if you get a smoke column going up and it interacts with that, you can get some really good spread that you might not otherwise detect based on surface forecasts, which we typically use in the Canadian Forest Fire Danger weather system. Another example of a refinement on predicting whether it's going to be a spread day or not is smoke. So many of you that have worked in fire, either wildfires or prescribed burns, know if you get cloud cover or you get a lot of smoke cover, that can often dampen fire spread. And so as we bring in maybe a couple more explanatory variables that can help us predict spread, we can refine that first step. Let's move to step 2, forecast the daily spread distances. This is empirical observation. BC has over 1,600 wildfires a year, and a lot of them are getting big. We have an incredible opportunity to make empirical observations of when those forecasted conditions in step 1 are present. What kind of spread distances do we get in our different parts of the province, whether that be the northern boreal, the dry central interior, the coastal mountains and rainforests, or the Rocky Mountains to the east. Let's move to step 3. We talked about this earlier. We then, do this buffering exercise, and we buffer out our values. Instead of growing our fires, we buffer out our values by those expected spread distances. And we constrain them to where we have hotspots overlapping. And so Carrie mentioned in her opening talk, we've got the wildfire SAT mission. We're also doing work with remote sensing, specifically Sentinel and Landsat, to be able to detect where we have fire movement. And I find one of the biggest challenges in predicting what these big fires are going to do is large portions of the perimeter can self-extinguish and other portions don't. And so really getting a handle on where do you have wildfire activity and where maybe have you seen self-extinguishment is important. But in essence, bringing that information into this and removing the buffers, reducing the scope where you don't have overlap with active fire and keeping the buffers where you do. So there's some science there around remote sensing that can definitely help us with step 3. As we move to step 4, this is what we haven't done yet, but we're very close to, is further constraining those buffers based on fire exposure pathways. So where you have continuous fuels and good spread pathways, maintain those buffers around your values. And where you have discontinuous fuel pathways, you may put those in a second list or remove them from your scope. And then the final step 5, what we're ultimately trying to do is to do that strategy and tactic exercise and provide focus to an incident management team or to a local zone. And so that's our work. That's what we're ultimately trying to do. And so if you are a scientist out there listening, steps 1 to 4 are for you, and they can really help us when we get to step 5. But we've been piecing together your work in steps 1 to 4 already, and we really appreciate all of the research that's been done. There's a lot of really other interesting things that are happening out there right now that I wish I had more time to talk about, but I think I will leave it there and pass it back to Carrie because there's a bit of a question period. And thank you for listening.
Great, thank you so much, Neil. There are, I see a hand come up, so maybe we'll, oh, it just disappeared though. So maybe we'll just go to the few questions that I've seen so far that have been put in the chat. And again, if you have any questions, feel free to put them in the chat or raise your hand. One of the first questions that did come in was, did Canada have a full suppression policy similar to the US? And so I don't know, maybe Hillary or Jane could take that one on.
Yeah, I can take it on as at a very general level. Historically, like many jurisdictions around the world, we did have a lot of suppression legislation come in place kind of at the turn of the century, kind of the late 1800s. A lot of our national parks and public lands were bound by kind of forest protection laws, and a lot of the early forest protection agencies, including Parks Canada, were based around suppression. Some of that has changed in certain agencies. Currently, most provincial wildland fire agencies have kind of potentially a mixture of suppression, full suppression, and modified response, but it varies by agency. As Hillary mentioned, in Parks Canada, we have kind of a zoning approach where there are areas that have full suppression around our critical infrastructure and communities, and then other areas where we allow fire to play more of its natural role. So in general, yes, we did have a kind of broad scale suppression legislation across Canada for a very long time, and some of that is starting to change somewhat depending on which agency you're with.
Thank you. Hillary, did you have anything to add, or are you good?
No, not much to add, just kind of, yeah, I think one thing though too is like a lot of agencies do have the ability to kind of let fires go, but it is kind of always risky. You get more benefit of suppressing the fire because then nothing happens, because then if you don't suppress the fire and then like a couple months later something happens, then you're always going to be questioning that decision, and it's going to come back to you as a decision maker. So it can be tricky sometimes, even when you feel like in your gut it's the right decision to let that fire go and do its thing naturally. It can still be a hard decision to make.
Thank you. Another question, is there a similar tool or data set to land fire for Canada? Dr. Beverly or Neil, did you want to take that?
To my knowledge, no. My understanding of the land fire program is that it's primarily a consolidation of data sets and information of various fuels data sets and fuel models and that kind of thing. And to my knowledge, we don't have a centralized program like that in Canada. I don't know, Neil, if you want to elaborate.
Yeah, I'm not aware of anything either. I think one thing to be aware of in Canada, due to the way Confederation worked out for our country, each of our provinces and territories are essentially self-governing. And one of the things that plays out in that is that each government kind of does their own thing. And there's often incentives to do that based on whatever political party's in power. So it can be hard to really rally the country together to do things at a national scale. We're really trying to do that now with organizations like the Canadian Interagency Forest Fire Centre and the Canadian Forest Service with Natural Resources Canada. But it's been slow and it's been difficult. And so using the Canadian Interagency Forest Fire Centre as an example, they have endeavored to try to start to bring data across Canada together into common data sets. And we've got a couple examples of that using common data standards. But again, it's been slow, and we don't really have good national programs where all of the jurisdictional data is available in one place. And what makes it even more confusing is our federal government has what we'll call national scale data, which is different than what the data that provinces and territories may be using. So that's where we're at. I would say there's a lot of interest and effort that's being made to accomplish something to land similar to land fire, but we're not there yet.
Great, thank you. And Jane, did you have a comment on that, or?
No, I was going to just comment on some of those kind of national data sets, but the same point that Neil made, so.
Okay, awesome, thank you. Dan Reese, I see your hand up, please go ahead.
Well, this has been a fascinating presentation. My adult life has been surrounded around suppression and understanding the need for certain fires to burn and certain fires to not burn. And the picture that you've all brought collectively with all the research that's been done to me is fascinating because it shows a couple of things. One is where fires do need to burn, and then the concern with the WUI and the interface about, where do we do point protection and when do we make the decision to suppress a fire? So I guess my question really leans towards suppression in Canada, because I'm not familiar with Canada. I'm from the lower 48 here in the US. And we've got hundreds of millions, if not billions of dollars that are spent towards suppression and even towards the hardware of suppression. And so everyone is trying to say, well, how can we be better about suppressing where we want to, when we want to control certain fires? And that's often limited on a culture that's been built around using long-term retardant to try and slow fires, get out in front of them, do whatever we're doing to help firefighters. And with that, it's discerning to me, because my background in the US with chemicals and CAL FIRE and the research that I've done with the federal agencies and national agencies is using chemicals maybe that aren't so harsh on the landscape and are built and designed to actually suppress fires versus slow fires. So for those of you in Canada, when it comes to that, that means using things like water enhancers. So if we effectively go to where you all are researching where we can be effective in using that in Canada, where are you going in policy, I guess? And I know it's fractured based on the provinces for utilization of things to incorporate like water enhancers versus long-term retardants to be able to accomplish the objectives that you see actually being able to be met. Because right now, everything, to my knowledge, when you talk about suppression, is built around something that's designed to slow a fire, where we use billions of dollars worth of hardware and expenses to do it, versus stopping a fire with water enhancer. And it's a loaded question, because here, even in the United States, it is a brutal thing because it's not vogue to use something to actually suppress versus slow. Where do you see that happening in Canada? Is it a reality?
Who wants to take that on?
I'll take it on a little bit. I don't work in the air tanker program, but I know a little bit about it. I know that we are testing chemicals used in retardant, and we've got a couple research organizations like FP Innovations that help test the efficacy of some of those chemicals. But we also have environmental standards around some of those chemicals, and it is a contentious topic. When you see, red painted across a mountain or, going across a waterway, it's often not desired, especially in sensitive areas. And so what I would say from the BC context is it's a bit of a double-edged sword in that large communities are being threatened every year by fire, some communities multiple years in a row, and would really just like to see blue skies again. And so I think they're looking for agencies to do what they can, but at the same time, we do have those environmental policies to uphold. I think from a BC context, we are using when we use air tankers, we do not view it as a stopping mechanism. If we can't get crews and equipment behind air tanker drops, it is viewed as just slowing the fire down. It's not going to put it out. This year, Dr. Beverly showed pictures from a fire in the Chilcote, and we had lots of dead and down woody debris from mountain pine beetle infestations. Dropping air tanker loads on that wasn't even effective because it couldn't penetrate all the dead and down woody debris. And we've got the same problem starting up in the north, which I shared in my slides. And so we do view air tanker drops as a mechanism to slow the fire, help with initial attack until such time as we can get crews on it to start actually containing the fire. And so that's how we use it. But another tool that's used, I would say, just as much in BC is burnout and ignition operations. And I would be fascinated to see some research done on that and how we, can effectively use burnout operations at different levels. So that's as much as I can share. I'm not an expert in air tanker chemicals, but it's an interesting question. It does pop up in the media in BC every now and then around, oh, should we be dropping those chemicals in the forest?
Thank you. Neil, how tough are you to get a hold of?
You can reach me.
Do you have an email you can drop in the chat?
Yeah, absolutely.
Thank you.
All right. Thank you. Anyone else have comments on that one? Okay. So moving on then. Is there any kind of FWI forecast available for Europe? And I'm not sure if any of our speakers can answer that one, or maybe that's a Fabio question.
I personally don't know. I was Googling before I gave this presentation on how widely like the FBP and FWI system are used in Europe. I think they're used in certain spots and there might be some platforms for getting that information, but yeah, maybe Fabio is better to speak to it.
Sincerely, I don't have this information that we are using the FPP in Europe.
It's
In my
very
case,
easy
I'm not
it's very easy to stand up. If you wanted to create those forecasts, you just need daily temperature, relative humidity, wind speed, and precipitation. And there's a lot of different open source code repositories or software tools that can be used to calculate the values. So if you were interested in it, it's fairly straightforward to set up, and it is used throughout the world in many other countries. So, but I don't know if there's a formal organization that's calculating those values.
The way that the FPP, the way that I saw, sincerely in the last, we are using a lot the FWI, in the pure mode, but in the FTP, I think I don't know if the European platforms we are using or not. In my case, I'm not using, but I believe that for sure it's very simple. Paulo Fernandez is here for sure, know better than me if we are using or not.
Well, we are now in the process of finishing equations, FPP style, for full types in Europe. So based on both experimental and wildfire data. So for now, we have equations for basically pine and eucalypt forests, and then another equation for woodlands and shrublands. And they work pretty well, surprisingly.
That's awesome.
Great, thank you. So next question, Stop the Spray Canada tells us that spraying of glyphosate is desiccating our forests across the country, causing them to become tinderboxes. Is there any political will to stop the spraying as one of the cheapest and easiest fixes in our toolbox?
I can
Any
say a
thoughts,
couple
anyone?
words on this. So the Cascatna fire I was on was interesting. I was seeing strips in the forest, conifer strips, and then deciduous strip and conifer strip. And I said, is it just me or am I seeing stripped species in the forest? And the helicopter pilot's like, oh, I know what that is. That was from spraying. One of the nozzles broke and they were leaving strips as they were spraying. So it does happen. It is quite controversial here in BC. There are a lot of advocates suggesting we need to enable more deciduous forests, which are often more resistant to fire spread than our coniferous forests. And so you'll see that in media posts and blog posts a lot here in Canada and specifically BC. When you look at the numbers, the actual area that's being sprayed isn't that much, but it's obviously having an impact in those areas. I cannot speak on behalf of my government or my ministry if there is interest in shifting that. But what I would say is that as you look at those area burn statistics I shared, our land managers are really having to kind of scratch their heads and think about like, what does the future forest look like? And reevaluate maybe typical forest management planning principles where the rate of fire disturbance is far outpacing what they would typically have expected in a planning horizon. And so I think that alone is going to cause a bit of a shakeup. And I mean, the other challenging piece in the BC context is these large landscape fires are literally shutting down mills. It's consuming their entire operable areas and woodlots and making the business of forestry unsustainable. And so, again, I think a lot of these factors combined are going to have that industry having to figure its way through this really challenging time. But I can't speak to whether there's any expected shifts in government policy around spraying to reduce deciduous tree species.
Thank you. Anyone else have any comments?
I just mentioned in the chat there that for both retardant and spraying, that's not generally things that we do in the national parks for environmental reasons. We do use retardant on occasion if there are communities adjacent or within the parks, but generally we don't use them.
Thank you. Another question. Fire runs influenced by atmospheric instability and convective activity. To what extent does the FPB system do a good job in those situations? Is that a Hillary? I think that's a Hillary question.
I can at least start it. The FPP system has like a number of rules and set criteria that it's meant to be worked in and applied in. And once it's for and derived from wind-driven fires. So once a fire does become convective, it loses its applicability. So I guess the answer to the question is it's still often applied as to get like a guess as to what's going on. But once a fire becomes convective, the FPP system can no longer be like directly used, and it's not meant to be, because it's kind of the fire's deriving its own weather at that point. Does anyone else have anything to add?
No, it's a great explanation. If I were to add one thing, I'd say if you look in the documentation for the FPP system, and they do a neat job of like overlaying the empirical observations on a lot of the mathematical curves that are part of that predictive system. And then you plot the conditions that we've been seeing fires over the last decade, and we're way outside the bounds of the empirical data that inform that system. And so I think not only is it challenging to use that system when you're outside of the assumptions and limitations of the system, but also we're setting new records every year in fire weather. And we have to acknowledge that it's way beyond the curves that were developed. So.
Thank you. Jen, did you want to comment on the next? There's a question here. It was very interesting to hear about Dr. Beverly's research around vulnerability assessments. Did you want to speak to that one a little bit?
Yeah, sure. So absolutely, these assessments are being used to inform fuel management. So Neil highlighted some applications for looking at operational priorities and when you're managing active fires, but both the exposure assessments, which can be done at a landscape scale, but also within the built environment, and those radial graphs of directional pathways, those are being used right now by multiple provinces, provincial agencies in Canada to prioritize the most at-risk communities for sort of as a course assessment to say, hey, here's our top 20 or our top 30 communities, the most directionally vulnerable, for example, the most exposed, as a way to then go in and do further assessment at a more localized scale to prioritize the actual positioning of fuel management treatment blocks. So those would be going in, thinning out a forest stand, removing some of the trees, changing the architecture of the stand by removing lower limbs and potentially removing some of the surface vegetation as well, to reduce the potential for that fire. If a fire impacts that area, if you do these fuel reduction efforts, the hope is that the fire will not access the crown fuels. If it can't access the crown fuels, then you're limiting the potential for embers to rain down on structures and ignite the built environment. So absolutely, it's being used, again, sort of at a core scale by multiple provinces, and it's also being used by multiple communities. We've actually assisted 9 case study communities just in the last couple of years in Western Canada to do these in-depth assessments and have made those maps available for positioning in a more surgical way where you might attempt to cut off a pathway, either by reducing the fuels or even considering a scenario and strategically positioning containment lines that could assist operations, for example, for an ignition operation. So proactively going in and setting up assistive fuel managed areas with an operational mindset to stop a fire encroaching in along a given pathway, for example. And those might be combined with other features on the landscape that are fire limiting, like water bodies, lakes, and rivers. So you might have, say, 2 lakes, and you've got a pathway for fire in between them that's leading right into a community. You could consider proactive fuel management specifically to cut off those pathways. And I put a link to a paper online. You can take that kind of scenario planning exercise to a more analytical, sophisticated level with optimization modeling. And so there's many ways you can take those assessments as an input to more sophisticated modeling to really hone in on, hey, where is the optimal place to allocate fuel management interventions?
Thank you. I think that is all of the questions that I can see in the chat right now. I don't know if anybody wants to unmute themselves or put up their hand if there's any other questions. I know I did see a few other hands show up and then they disappeared again. So I'm not sure if that means your question was answered or please go ahead. I cannot even begin to attempt to pronounce the name that I see on my screen. I apologize.
Probably that's Greek name, Gavril Xanthopoulos. Okay, what I have noticed here, I have heard very good science, but very good operational experiences. And what I think the problem becomes worse very quickly, and there should be some attention, I think, to the communities themselves, to the ways the buildings are built. Because for a long time, this is the main difference I've seen between the Mediterranean areas where we live here and the places like Canada or Montana, for example, where I studied. It's the way the houses are built. With the quality of firefighting that you have, if you had less worry about the construction of the houses, less vulnerability, you would be, let's say, your head would be free and your hands would be free to work more on the fire, I believe. I would like a comment from that about that.
Thank you. Who wants to comment? There might be a few comments here. Who'd like to go first?
I could just note that, you know, our panel, it doesn't, yeah, you're right. We don't really have a, I think, strong representation from that. The other disciplines associated with fire smarting includes looking at building materials and looking for opportunities to enhance building codes and other regulatory frameworks that might motivate, I guess, proactively using, you know, construction materials that are less fire prone. But the assessments that we're doing are being used by communities to talk to homeowners at that property scale, show them that their structure is heavily exposed, for example, and that information can sometimes be compelling enough to motivate investment by homeowners on their properties, to make them to harden their properties so that they're less receptive to ignitions. And that could be if there's an opportunity to go and change their roofing materials. When they're going to go upgrade their roofing materials, then they may be more likely to use a metal roof, for example, than a shake roof. So some of the methods the tools we're developing can be used to inform where you might want to prioritize better building. And there are active efforts to develop new building codes to motivate, and also through the insurance industry to motivate those kinds of investments in building.
Yeah. Thank you, Jen. And I can speak from, you know, my municipality in particular, from the municipal side of things. We have several incentives in place for our residents to help offset some of the cost of things like replacing your roof. For years, the town of Banff, you had to actually put on a cedar shake roof when you built a house in the community of Banff, and so now through changes to our land use bylaw that has been adapted in the last several months, you can no longer put a cedar shake roof on your house, and we've opened up the possibility so that you can put single seam metal roofing on, because you couldn't do that before. So some of those changes are starting to take place, and more of them need to take place, but unfortunately building code is, you know, years behind where we need it to be. It just takes time to get that up to speed. So some communities are building back better. Certainly Jasper, as it rebuilds its homes, are building back better to more fire smart standards. So yeah, so that's some of the stuff we're doing there. Another question, what type of operational airborne thermal observations take place in Canada during wildfires? And does any of that data get used for scientific purposes?
And take a run at that one.
Sure.
We use a variety of methods to capture fire progression, essentially. And I would say the two long-standing methods have been an aerial GPS, often in a helicopter. But on some of those big fires I shared with you, it becomes almost impossible to fly the whole perimeter, and it's not safe when you've got those big smoke columns going up and lots of aircraft in the air. The second would be high-level scanning with onboard sensors doing infrared and hotspot detection. Our challenge with that technology has been they need certain airports with oxygen, and they need to be able to lift off from those airports. And in recent fire seasons with turbulent air, smoky skies, they just haven't been able to get the right flight conditions to fly when we needed them. One of the new emerging technologies that we're seeing used a lot is drones. And I think there's some really interesting innovation happening in the drone space that will allow them to start to fly beyond line of sight and cover a lot larger areas. And we, you know, the Cascatna fire I was sharing with you earlier, we use drones almost exclusively to look for hotspots as well as update our perimeter for that fire. I think we could be doing more with those technologies, but that's where it's at right now. And then the last one is using satellite data. So we're doing a lot with Sentinel and Landsat data to capture fire perimeter updates as well.
Thank you. And I see a link here to Fire Smart Canada Home Development Guide. Thank you for posting that, Leah. It's a great resource, and we certainly share that with all of our residents. Let's see, another question. For communities in the WUI and remote areas, what practical steps would close the detection gap, especially for night smoldering starts and days with heavy smoke without overwhelming responders with false alarms? Jane, can you speak to that?
Yeah, I mean, generally we've been, using some of the NASA-based products. Obviously, Wildfire Sat, as that gets launched in Canada, will hopefully provide some kind of a more local solution in Canada. So, you can set a number of alarms on even the NASA platforms to kind of inform whether hotspots have been detected in your area. And so that actually has worked in terms of detecting some new starts that, we wouldn't have otherwise kind of found necessarily, just because they're either from human starts. So we don't know that, a lightning system has come through that area. That being said, it is still imperfect, especially in the mountains. We do get a lot of, we call them hot rocks, basically heat signatures off of rocky formations, which, as you can imagine, in the mountains happens fairly frequently. So yeah, that's kind of the general thing. A lot of the provincial agencies also have remote cameras, and using AI to detect smokes, kind of using that camera technology. In parks, we haven't gone that way necessarily, but we have a much smaller land base than most of the provinces. But yeah, it's generally satellites and remote cameras, and then the kind of aerial, using aircraft and crews. I think with the drones that are getting easier and easier to use, and maybe even cheaper for agencies to use, I think, and then with the not needing the line of sight, I think that'll also kind of change things as well. But a lot of that technology is constantly evolving, and the agencies are trying to keep up. I don't know if Neil, you might have something from the BC side of things.
Yeah, one simple thing we did that's been quite effective is we have a mobile app that shows a map dashboard of where all of the active fires are in the province, but you can now report a fire through that app. And when a person does that, there's an option to upload a photo. And just simply adding the option to upload a photo has been really quite effective at helping us sift through false alarms versus actual fires. People obviously are quite concerned when they see potential smoke around their communities and are very active at reporting those to BC Wildfire Service. But a picture can help you tell, oh, we already know where that fire is. That's already been reported, or that's dust off of a forestry road, etc. So that simple measure has been very effective. We're also exploring the use of remote cameras. So in and around communities, being able to look with a camera to have a second set of eyes, essentially, on what people are reporting. Our biggest challenge is fires that start in backcountry areas where there is no public detection. And when we have big fire seasons with lots of smoke in the air and don't have the resources to do patrols and don't have the ability to even fly because there's so much smoke in the air, you can get new starts that go undetected for days. And when you find those fires, you're finding them in VIIRS hotspot data as a big fire. And so that's a challenge for us, as those more remote fires that don't have a public detection network that we can leverage.
Great, thank you. Are there annual or multi-annual targets set on wildfire management in Canada? We're missing this in Europe, just comparing each high-risk season's burned area with previous ones.
I don't know
Some
if
of
they're oh, sorry, go ahead, Neil.
I was just going to say some of the agencies have performance metrics, others do not. But Hillary, you might have a comment that's more specific to that.
Oh no, I was just gonna say the same thing. It kind of depends on agencies. Like in parks, even like the specific parks might have like a goal of like area to be burned primarily through prescribed fire. But each agency functions pretty differently in Canada in terms of their goals and areas burnt.
Yeah, and just to build off of what Hillary just said there, in terms of our area burn targets within Parks Canada, because we are primarily ecological integrity-based mandate fire agency, and we do try to allow fire to play its natural role in the ecosystem, those targets are based on ecosystem fire restoration targets. So we're aiming to encourage fire on the landscape to a certain level. And so our national area burn target is 20% of the historic fire cycle across all of the fire-prone ecosystem parks in the system. In the mountain parks, we've had a much more busy prescribed fire program over historically. And so our target is actually 50% of the historic fire cycle. And obviously that depends on kind of the ecosystem that you're talking about in terms of what that area is. And in Banff, for instance, it's it's approximately 1,400 hectares total per year as fire, whether it's prescribed fire or through wildfire. But obviously the suppression-based agencies would have kind of a bit of an opposite objective in terms of area burned and trying to maybe reduce the area burned over time, especially in commercial forests or places with timber values and other values.
I think too, just building, oh, sorry, Carrie.
Go ahead, Hillary.
I was just gonna say, building off that like a little bit too is just like having one metric describe a complicated process on the landscape can be a little bit tricky, like there in some instances like fire can be really good for a certain ecosystem and then the intensity of it in somewhere else could be bad. So having like it's not necessarily apples to oranges everywhere, and different landscapes across Canada have different like burn intervals and whatnot too, and ecology in relation to fire. So I'll just say that.
Thank you. I don't see any other questions. I don't know if there's anybody who has a last minute question that wants to put their hand up. All right, well, just a comment from Jane. Okay, well, I don't see any other questions. I will turn this back to Fabio, and I will just say on behalf of all of us, thank you very much for providing us this opportunity to share just a small piece of wildfire management that's taking place here in Canada. Fabio?
So thank you so much for your presentations. It was amazing. More than 3 hours is amazing and very productive webinar. Thank you everyone for participating. And so we will share this recorded in our YouTube channel in a few days. And again, thank you very much for your efforts, and see you in the next cafe webinar. Thank you.
Thank you.
Thank you, Gravel.
Bye, thank you.